Ready, fight!
Hello everyone, welcome to the first lecture of project building. So in this project we are going to build Play Atari game using Python. So what is this project about? So whenever you have visited into the mall and whenever you have visited gaming section, you have came across a TV screen, and basically it have a webcam, and they have a game that whenever you dance in front of those screen, they score you. So how does this work? Basically those work based on the data science concept known as random forest. So what happen is that whenever there is a LED TV camera that detect your posture, and they have random forest attached to it, and they give you score based on that. So today we are going to build the similar kind of project but in much simpler form. So we don't going to be in much depth detail for random forest. We are just going to detect the posture, basically using MediaNet for this and building our project. So I will be attaching a research paper on the following game that this uses random forest that Microsoft has released it. And now let us look on to the project building. So what we are going to build? So we have a TV screen or laptop or monitor screen, and we have our webcam. So what it going to do is it have a OpenCV. So what does OpenCV library is about? So OpenCV is Open Computer Vision. It is a Python library for computer vision that, and then we could use any machine learning algorithm or artificial intelligence algorithm on it. And basically after this we will be using MediaNet for the posture detection. What is MediaNet? So MediaNet is a Python library which is maintained and built by Google, so detect posture, and we will be using those to detect our posture. And then after MediaPipe, we have going to use a next library, that is Pi Auto GUI. That is for this library. What it does, it uses a keyboard to press the button. So whatever our posture is, and based on that, it will press button on those keyboard. And next we'll be using NumPy for our pixels based manipulation. So now let us check. So now let us look at the doc. So here are the documentation that we are going to use mainly. So first one is MediaPipe. This is built and developed by Google, and it is open source. So basically it does detect the posture, and let's have some ML algorithm behind the screen, so we don't have to worry about that. So I would highly recommend you to go have an overview of this documentation. Next we have NumPy documentation. It's we are going to use heavily in this course. Have a overview of this documentation. Basically in data science section, we are going to use this in heavily. So, and we will go through this in much more detail in data science section. Next we are going to use OpenCV. So OpenCV is a computer vision algorithm, so where you could use your webcam or CCTVs and apply ML algorithm to it. So here are the some functionality methods that we could use, and I will highly recommend you to go and check out this documentation. Next, let us start to code this out. So for this lecture, we are going to play this game, that is Stickman Dragon Fight. I downloaded it from Chrome Store. It was basically a random game, so I thought it was cool to play it. So basically, when you play it, let us load it out. So basically, it have when you play this game, it have lot of control. But basically, we will be using space for a combination of fight and legs. Here you could see that we are using only space for combination, and then we have W button for our special attack. So we are going to implement those two features to play our game. That is, if we show the punching move, so it or character would play, and we are going to have W for our special attack move. with this, now let us code it out. So now here's the documentation for MediaPipe. So what we are trying to code out next is that we are going to detect the distance between the landmark 16 and 10. So if it's like very far away, then it's mean punch, and if it's very close, then it's mean defensing, and we will use a special attack for this. So now let us code it out for our code. Now moving on to this, and now it's coding time. So first library we need to install is MediaPipe. So to install any Python packages, in previous Python lecture, you know that we need to install it through pip install, and we are going to install MediaPipe. So MediaPipe, and then enter. So I have already installed it. It won't take too much time. Then we need to install OpenCV. To install OpenCV, we need to have the command OpenCV / Python to install, if I'm correct. So yeah, I have already installed it. To install NumPy, it's pip install NumPy, and we have already installed. And for the last one that we need to use is PyAutoGUI library to use our keyboard functionality. So to install it, pip install PyAutoGUI library. So it should be done. I have already installed those libraries, so it won't take too much time in my machine. So first we get the logic for this code. So once you go through the MediaPipe library, so these are the vertices, that is pose landmark. So once our pose is detected, so what we are going to do? So how to detect a punch? What if we are doing that pose? So if the distance between the vertices 16 and 12 is greater than 90 width, then it is a punch position. And if its width is closer, the wrist width is closer to 10th vertices, then it means defense. And this is we are going to code out. So first, and now it's time to code it out. So first we go through the docs for MediaPipe. So here, once MediaPipe detects our posture, here it added some vertices onto it. So for our wrist, it's 16, or mouth and face, it's 10, and or for shoulder, it's 12 and 11. So what we are going to do is, if the distance between wrist and shoulder is pose landmark 12 is greater than 19, then it means punch. And how to detect a special attack move? Then it should be closer to our nose, that is vertices 10. So we will code this out together. First, we will import those library. Import MediaPipe as MP. Now then we import CV, then we import NumPy, we import PyAutoGUI, then we have capture to start capturing or video camera. So to capture those we call CV2, and then we call video capture, that captures our web camera. So 0 is the index that it captures. For pose detection, we have pose is equal to mp.solution.pose to detect our pose. For drawing those landmark points, we call mp solution. So solution.drawing utils. And then we called object for our pose. Pose.pose. Now we declare two variables, space down to check if the space button is pressed, and for another variable w down, boolean that detects if the w button is pressed or not. So space down false, w down is false. Now we loop hold. Now we will loop each frame and we'll detect those posture, and based on those we could have our character move those buttons. So we loop whole frame. So we remember the while loop, then we go to this code cv2 dot read. So what does it return? So cv2 returns two variables, that is if the capture have been done successfully or not, and one frame matrices that is in matrix format. So we will iterate whole frame each by each. So res object dot process, and now we'll detect the frame each by each. cv2 dot cvt color, and then we pass the frame. It takes a frame as a parameter and the color. For this we will pass cv2 dot color, and then we need to pass the parameter, that is bg2 bg2 r2 rgb to rgb. Good. Now we will draw the lines to it or frame. So drawing, draw. So first here I have spotted a typo, that was a dot on it. So now we need to draw the lines to our drawing. So drawing is equal to, and then draw draw landmarks, that is those vertices that we saw in the documentation, and we pass the frame, each frame to detect it, and then we pass the parameter what to detect. So pose landmarks res or pose landmarks. And then we connect all those. So now it's time to code out the logic that we have made for or punching and or for special moves. So we know that if it's greater than wrist and shoulder, it's greater than 90, it's punch. If it's relatively closer, then it's a special attack move. So we will code it out if rest. We first check if the frame have been detected for our rest pose landmark, and pose landmark or wrist is been visible to the camera. So we'll first check out those. If rest dot pose landmarks are there, and rest dot pose landmarks 16, the 16 denotes the vertices for our wrist, and if its visibility is greater than 0.7, then it's mean it's have been detected. You could tune the parameter for your preference and based on your camera. So x is equal to absolute value, so it should be non-negative, and press dot post landmarks dot landmarks, calculate the we calculate the distance between the or wrist and or right shoulder. So we calculate the position into x, into x part of those x position, and we calculate the multiply it with 640, which is the frame. Then we subtract the x position of with the shoulder part of it. So rest dot was landmarks 12 dot x, and then we multiply it with 640, which is our frame width. I think this is cool. If the distance is greater than 90 width, you could also tune this parameter with yourself. You could make it 100 times for your wrist. It's up to you. And then we print it first. Okay, there or kick punch combination are detected. Combination detected. Okay, so punch and kick combination detected. Cool. Once it's have been detected, if not space down, if space is false, then it must be, if space is pressed, we need to press the space. So if not space down, which means if space is true, like if it's strong, we space down it. Pi we space down it, key down, because and we press the space. So here, when I coded initially this code program, the space was pressing only one time, and for a punch key combination, it was not good. So I have to make it 3 times. So it's a good combination. So we key up those, and we do it 3 times for our combination. Cool. And then if it's the space down was false, so we made it true. So if rest.pose and or landmarks, if it's there and rest pose is also being detected, those landmarks is also being detected, and its visibility is greater than so let's get that point. And if its visibility, so if it's detected, that means the landmark pose is detected, so your wrist is being detected, and the visibility criteria is greater than 0.7, that means it's been detected. And now we run our code. So what we are going to do this. So now we are going to run our code. So what we are going to do next is so now once our wrist is detected, we are going to calculate the distance between a vertical point, that is 16, that in our documentation, and between 10. So if distance is greater than 90 like pixels, so it means it's punch. If it's less than that, it means it's in fence criteria. So now let us code it out. So x is equal to absolute value. Then we calculate rest.pose landmark 16, that is our rest. And then we multiply the absolute value with the pixel width, that is 640, that is standard pixel width. We are going to multiply it with, then we calculate the rest position of the nose landmark, that is at 12. So next what we do is, if space button is not down, like if it's pressed, we need to press it up again. So X is down, sorry, the space is down, we need to space key up the stroke, upstroke the key button. So pi of the GUI dot key up, and is equal to what we need to do is we need to space key up the word, and then we need to make the space down boolean as false. Next, we will need to code out for our special attack move. So if res.pose landmarks 16 and its y position multiplied by 640, which is pixel width, is less than res dot pose landmarks, and which is odd 10, which is our nose, mult dot y position, then it's mean our special attack move. So we print special attack move, special attack move. Okay, so type through here special attack move. Now we print the button if it's false, then if double down, we not double down, we pi auto GUI dot, we press the button. To press the button, we need key down method functionality, and we press button W, and we make the variable false. Cool. Else, if it's already down, then we need to up the button. So here is a typo from here that it needs to be true, because once the button is down, we need to up it. So once if W here we false it, the whole logic would be wrong. So it needs to be true, so it could go on to the else statement part also. Now it's time. So the logic for the code have been implemented. Now we have to move exit from the windows when the escape button is pressed, or and we also need to show the window of our camera. So for this, we have okay from frame CV to clip, and we show each frame by frame. Okay, and now we show this. I am to show the frame, so we use window to show the frame and pass the frame to it. Okay, so here we are using the flip. So once the image goes to the camera, we need to flip out to show it correctly, else it would be a little bit odd to show on the device. And then we need to if we are done with the game, if we press escape key, then the program should automatically get cancelled. So we need to code this out for if cv2 dot wait key, that is 1 is equal to 27, What does 27 integer means? It's mean for escape button, and then we destroy everything. CV2 destroy all windows. Also, you could see the clean coding part, the camel casing. The first part is small, and then all the next part is capital on all capital. So we then release cap dot release method, and we break the code. Yeah, I think with this our code is complete. Now let us compile our code. Python gameplay dot py. So now here have we some issues. Now we need to fix it. So first issue is saying that we have error in line 32 that expected is. So now the error is that we have given a condition on else statement. Else statement never have a condition. So we just remove it and run our code again. So we look at that break was out of this. So here is so next error is that break outside the loop. So if we check our code, we could see that we have make a typo mistake. This should be inside the while loop, and these two codes should be also in while loop. So we indent it into the while loop, and it should be fixed now. So our next issue is that media attribute has no solution. It's have solution, so it should be solutions, and now we fix it. Wait for it to run it. CV2 read has no output read, which is on line 17. Here the CV2 is don't have directly have read. We need to get the read function from the capture video. So it's, instead of CV2 it should be capture. Clear out the console, python.gameplay.py, and it should be running. So now let us wait for some time. Now let us wait for some time to compile it. Okay. So the current issue was that our code needs camera feedback, and the camera was running to record our video. So I have stopped it, and now let us run our code. Hopefully it should run now, and let us run our code python.gameplay.py. Now all the vertices are getting detected, so it's clearly showing me that is defense position. Why? Because the x coordinate vertex is here is close to this 10th vertex. So now let us check for punch. Yeah, it's working. Now let us play our game. Now let us play our game. So currently it's detecting the defense position, and let's punch our combination.